Good day, everyone. I am Prof. Rolf Morstedt, and I'm going to introduce you to our department and the career of metallurgical engineering, which we believe is very exciting. So metallurgical engineers are magicians, and this video is going to demonstrate that. Let me show you why I say that. In this video, you will see this metallurgist taking the coiled spring and then deforming and bending the spring severely. So after he's done that, you can't recognize the original shape anymore. So now he's going to take that deformed piece of wire and he's going to heat it with a lighter up to about a temperature of 75 degrees C. You'll see that happening now. So first he takes it to a pair of pliers, and now comes the lighter, and this is where the magic happens. Watch closely. So as if by magic, this piece of wire now jumps back to its original shape. Can you do that at home? I don't think so. So the reason for it is that this wire is made of a very special type of alloy. It's called nitinol. And the nitinol comes from two elements which are the main constituents of the wire. Nickel, which is a Ni, and Ti, the Ti stands for titanium, another metal. And it was developed in the Naval Ordnance Labs in America quite some time ago. So this so-called shape memory alloy is used in a number of advanced aerospace applications. So imagine an umbrella-shaped antenna attached to a space shuttle. So that antenna will be too large for the launch. What happens now is they form the antenna from this nitinol alloy and then crush it into a small ball. So now it's able to be sent into space because it's small and convenient. And once it heats up to the correct temperature, the ball of nitinol then deploys into this umbrella-shaped antenna. The reason for the shape change in nitinol is due to the change in the arrangement of the atoms as the temperature changes. So metallurgical engineers deal with minerals and materials at the atomic level and use what is happening there at the atomic level to influence the bigger equipment, the bigger picture, like the space shuttle. And this is why we believe that this field is so interesting, going right from the atomic level up to the massive structures like a space shuttle. So in the world of work, where do metallurgical engineers fit in? The scientists that explore the crust of the earth and will locate the valuable minerals are called the geologists, and they are at the left of the slide. So this life cycle that we refer to as the minerals life cycle starts with the geologist, and he then points to where the ores are in the crust of the earth. That doesn't help us a lot. We need to get it out, and this is where the mining engineers then come in, and they bring the mineral deposits, which are often very valuable, diamonds or gold, and they bring it to the surface of the earth. And this is where the metallurgical engineer has to take over. The metallurgical engineer then needs to convert these raw minerals, which look like rocks and ore. They need to convert that into the valuable metal or material, like gold or titanium, for instance. And then they need to take it one step further. They need to manufacture specific components, like the blades of this athlete running there, or the space shuttle that you see in the top green spot. The metallurgical engineers need to convert those materials into components or equipment that functions, and it functions well, and it doesn't break. So this life cycle of minerals can be summed up by the slogan, minerals from exploration to utilization. And the first step of this life cycle for the metallurgical engineer is called the minerals processing life cycle. But just a bit of an interesting information that I want to share with you. Did you know that the University of Pretoria's Minerals and Mining Department have just been ranked as among the 50 best in the world? And this is a major achievement, and we're very proud of that. And it means that you'll get top-class education and exposure within our department and faculty. So let us return to that nitinol shape memory alloy. I said that one of the components of the spring is titanium. And the good news is that titanium is a mineral which we have lots of in South Africa. In fact, we have so much of it that you can see it lying on some beaches. So the dark sand shown in this photograph on the left-hand side is in fact not oil pollution as you might think. It is minerals which are rich in titanium. And now we need to get the titanium out of the beach sand. And here we have a magnet which has been put into the beach sand. And you can see that the magnet has attracted the minerals rich component of the beach sand, being called ilmenite, which is very rich in titanium. So this type of process where we beneficiate the mineral, where we start with a mineral that's not so valuable and that we take it to a more valuable, more concentrated mineral, is a part of metallurgical engineering that we refer to as minerals processing. So did you know that Africa has the largest mineral industry in the whole world? So another good reason for you as Africans to consider metallurgical engineering as a possible career. So the metallurgical engineer has a number of tools at his disposal to get the metal from the mineral out into something valuable. One of the tools that he has is that of heat. So using heat, the metallurgical engineer can melt the minerals, he can process it, he can clean it up. And what we have here is the pure metal then being cast into a ladle, a shape. And the reason why we cast it into that is that we need to have the metal, the pure metal solidified so that we can shape it into something useful that can be used by society. Sometimes the minerals are dissolved into fluids as part of the process of getting the mineral, like gold, from the ore. And this field of metallurgical engineering is called hydrometallurgy. And this is a view of a hydrometallurgical plant, and you see the various tanks and units at the back of this slide. Okay, so by now we have extracted the valuable titanium powder from the mineral. Let's look at this video to see how the metallurgical engineer uses his or her magic to turn this titanium powder into a racing car's brake caliper. This brake caliper must resist huge forces and not brake when the Bugatti car suddenly stops. Let's have a look. So here you see the Bugatti accelerating rapidly, and shortly you'll see that it is going to brake very suddenly. And this is where the brake calipers would kick in and it stop the car immediately. Just have a look at this. We'll explain this a bit later. This is now a metal 3D printer, a new process that makes the caliper. You'll see these little spots of light there. Those are lasers. And what you see rising up there is the caliper through the powder, the titanium powder that has been created before. And there's a caliper being tested at high pressures to ensure that it can resist the forces. So let's look at the video again. That's the final caliper that has been formed. The important point that I want to show here is this new manufacturing method of additive manufacturing. You can follow it by seeing these laser beams moving around in a certain fashion and the sparks flying. So this method is referred to as metal 3D printing, and it is busy changing the world. The process uses lasers, and those are digitally programmed to form intricate components such as this caliper. And before, you couldn't make a component like this. And the metal 3D printing now for the first time makes it possible to form this component. And this component is now stronger and lighter than any similar component made earlier with other technologies. So the metallurgical engineer is at the forefront of new technologies taking over the world. By now you may think that metallurgical engineers are magicians and that nothing ever goes wrong when one is around. Unfortunately, that's not always true. Sometimes components like this brake caliper fails, as shown here. Don't worry, however, the metallurgical engineers are here to use forensic analysis and investigations to work out what has happened and to prevent it from happening again. In South Africa, we have the largest 3D metal printer of a certain kind in the world. This is a photograph of a conventional metal 3D printer with a metallurgist standing in front of it. And on the right-hand side, we have a photograph of the Aeroswift metal 3D printer using powder bed laser technology. And it is the largest of that kind in the world. That metal printer is based here right in Pretoria, demonstrating that in South Africa we are at the forefront of this technology. This is a component made in the Aeroswift 3D metal printer, and it is, as you can see, a very intricate component, again very difficult to manufacture in any other way compared to the metal 3D printing technique. And it is a part of an unmanned aerial vehicle. It's in fact the frame of this drone. This is a part that has been produced in Bloemfontein, a very specific implant on the jaw. Now that implant again has to fit that human's jaw very specifically. Couldn't have been made in any other way than this. Again, new technology breaking new ground in South Africa. You might have read about this historic event a year or so ago. A professor from the Faculty of Medicine at Pretoria University, for the first time in history, did a middle ear transplant using a metal 3D printed tiny little bone. Again, something that you couldn't have done in any other way. This slide gives a bit of an overview of our department, which is the best metallurgical department in South Africa. So don't quote me on that, quote the Minerals Education Trust Fund. They have ranked us as number 1 in South Africa at the end of 2020 and also at the end of 2019, 2 years in a row. We have had a proud history of nearly 63 years of teaching and learning and researching. And our program is accredited by EXA, making sure that once you graduate and go into the world of work, that you will be able to register as a professional engineer. So this is a list of our industry partners. So you'll see some big multinational companies here like Sasol and Anglo American, but there are also some smaller startups that work with our department. They help us to do research, they fund some of our projects, fund our students in terms of bursaries and stipends, and provide work for our students after they go into practice. So let's look at the future. What will the future hold for metallurgical and materials engineers? In a recent book by a futurologist called Greg Seitel, a statement was made that material science may be the most important technology in the next decade. The reason for this far-reaching statement is that with the rapid development of new technologies, such as the metal 3D printing shown before, that new materials and metals will be needed for them. And therefore, the metallurgical engineer of 2030 will probably work with materials not even developed today. Another interesting fact, did you know that Africa's mineral resources are essential to the world's new digital economy and the transformation that we'll see in future to green energy? Another important future trend will be that of recycling of materials and metals. You don't know this possibly, but your typical smartphone requires 76 elements for its manufacture. In comparison, your body only requires 26 chemical elements. Where do these elements come from? Either from minerals from the earth's crust or from recycling our devices and equipment. So it stands to reason that in future, the circular economy and the recycling will have to become stronger if we want to continue develop new and better smart devices. But don't fear, the metallurgical engineer is near. By now, you know that the metallurgical engineer is a magician, so he'll steer society safely through these future hurdles. Do you want to become one? Join us in this fascinating voyage. Thanks very much for your time, and we hope to see you soon.